So I will switch between different topics. So the first is, of course, I come from research. I was research director at INRIA 4 years back, and I decided to move to business, launch a company, and from France we move then to US. So it's a long journey, but I will focus more on the technical challenge that we face today with the network in the cloud, and see what are the research opportunities and what is coming in this space. So how is working in this? Okay.
Use your own computer, maybe.
Yeah, maybe it's better. Okay.
No, it's change this one.
Okay. So just the agenda is first a little bit of context about the company, then the challenges, and I will introduce the application-defined infrastructure framework that we propose for solving a lot of networking challenges we have today, and then maybe a demo of Cloud River. So, the context. So I was leading INRIA Réseau team. We were focusing on high-speed network for high-demanding applications, and we participate to a large range of initiatives in France, in Europe. So the first one, it's okay, it's working.
No, but the presentation.
No, it's just a little bit tricky. Okay. So we started with data grid in beginning of 2000, and in fact it was a big data application. Then from this project we moved to data tag, and we were facing the limit of TCP in long fat networks. So all the work around TCP and high-speed TCP in this context. Then we launched this Grid 5000 initiative, which was, from my point of view, first cloud, and the idea of having resource on demand was critical, and we also spent a lot of time in building all these data center, facing all the operation and difficulties to set up, for example, the networks. We developed Hypernet, which was in fact the real basic IP for Cloud River, at least for the model underneath. Then we participate and also as a startup in European projects like Gather and Sail, and different things about flowware, networking, etc. So we transfer a lot of best practice know-how, software, patterns in the company. So today Cloud River is a SaaS solution available for cloud computing customers. So for example, AWS customer, Google Engine customer, and we will deploy Cloud River in any other cloud. So it's a multi-cloud solution for cloud performance analytics and optimization based on this application infrastructure framework, which take the network as a first-class citizen. So we simplify the cloud from the customer perspective with an abstraction. We develop an application infrastructure abstraction, and we measure it, we monitor it, we analyze it in order to improve the situation in case of over-provisioning or under-provisioning. We are a spin-off of INRIA. We got a lot of awards in France, and we raised in total more than $8 billion. Today we have more than 300 customers in production and trial, and we are partnering with Amazon. Hope we will have Google very quickly. We also partner with AppDynamics, which is an application performance management tool, saying clearly that we are not an APM. We are more cloud performance management. So it's a new category between the APM category and the the NPM, for example, Network Performance Management Tool. And the team gather 7 PhDs, and maybe it's not enough. There are a lot of technology underneath. And we have, background in SDN. We were developing an SDN controller at the beginning of the company. We did a pivot, so it's very important to pivot in a startup. So because the SDN market was not that clear, and it's still not that clear. So we moved to the application-defined infrastructure framework and perspective, which is in higher level, just before Nicira was acquired by VMware. So why putting the network as a first-class citizen of the cloud? So I'm focusing here on performance issue. Of course, the network is also quite important for security. And we know that the technology that we are bringing on the table helps a lot also in terms of security. But we are not focusing on this today because we find our market is more in performance. And the security market is quite crowded. Okay, so for me, cloud is here. So it was already clear in 2005 when we present our first paper on Ethernet at supercomputing. And it was not clear in Europe, clearly, that cloud will take off. It's really here now, and I think that last week I was at GigaOM Structure, and it's the presentation that Adrian Cockcroft did from, it was a former architect at Netflix, which is the biggest cloud customer for Amazon. Enterprise are now really embracing the cloud for mission-critical applications, at least in US. So it's clearly, here. For infrastructure as a service, it's about a 24 billion market in 2007. And if you look at the Magic Quadrant, Gartner just published last month, there are 3 big players, and that's what we really see. Amazon with 83% of the market, which is just, huge. You can think Google is a leader in the search market, but Google has about 65% of this market. Here we have a player which has 83%. So that's why when we did the pivot, we adopted Amazon. And I really wanted to understand what cloud is from the Amazon eyes, because Amazon is a retailer. It's not a computer, and it's just amazing. But we see, also Microsoft, Google, and we see a lot of startups in Silicon Valley relying on the cloud. So there is no question. The investors in Silicon Valley are giving money for a startup for building maybe the product, developing the business, but not for infrastructure. They have to adopt a cloud infrastructure. So let's go now to the network aspects. So the cloud is stressing the network. So now we have all this, massive scale, multi-tenancy cloud environment. We have business application on it. And we have seen that the network was not flexible enough. And that's why all this technology around network virtualization, software-defined network for opening the control plane of network devices to enable this programmability of the network, and all the initiative around open flow, but also open daylight, are for helping the cloud provider, or at least the physical infrastructure owners, to be able to play with their network and to slice them and dynamically reconfigure them. We have seen more recently the NFV movement for network virtualization function, or network function virtualization. So the idea is basically having distributed firewalls, load balancer, and lowering the cost of these equipments, which were appliances in the middle of the network. And So the network virtualization, the slicing aspect now provided by companies like VMware with NX6 or Contrail or Nuage Network, Contrail from Juniper and Nuage Network from Alcatel. So that's for provisioning, automating, and orchestrating this single virtual routers where the different VMs will be connected. But there is another aspect which is not really visible, which is how the cloud providers are sharing their network. And this is a very hot topic in research. If you look at the recent SIGCOMM, NSDI, HotNet, HotCloud conference, you have papers in this topic since 3 years. And the problem is that sharing this graph of resource of devices, which are multiple resources, and guarantee performance, guarantee bandwidth, for example, it's much harder than guaranteeing, a CPU capacity or RAM capacity. It's why this topic is still hot. There is another aspect which is understanding the traffic. The new traffic, because cloud is really disrupting the traffic model that we have for the internet, and we don't understand exactly what's going on, for example, in data center. So we start to see a lot of initiative in terms of DPI, deep packet inspection, from the network inside the network, getting these traffic patterns or being able to understand better what's going on. And from the customer, they are doing a lot of pings and decibel and very artisanal approach for understanding what's going on. And clearly, if you don't have performance in the network and performance guarantees in the network, you will barely predict anything for your application. So we see more and more, and with businesses and enterprise relying on the cloud for their application, we see more and more demand for this. So today, the network is bested for. There is no network guarantee, and from the customer point of view, it's difficult to understand the networking. If you do a trace route, for example, in Amazon, EC2, because in VPC you will not see anything. You may have 12 hops, and if you look at the routes, maybe 50 routes, different routes for the same flow. So this is, the way for example, Amazon is randomizing the traffic in order to avoid congestion. But it's good, globally for the scale. But from a customer point of view, it's not that comfortable for predictability. So the question that our customer has, so are there any noisy neighbor around me? And noisy neighbor means, you have an instance which is on a physical host which is shared by others, or also how I share the bandwidth, the backplane bandwidth in the data center. So the question then is how I place my cloud instances to meet my SLAs. How do I identify and remediate performance issues? And of course, it's a cost-performance equation to solve. So how do I reduce my bill without sacrificing on performance? So let's look at some findings. We compared Amazon and Google. So we found, for example, for latency when the network is loaded, quite different values in terms of RTT and throughput. Is there any something pointer? No. Oh. So really means that okay. So this random routing impacts. I will not give the detail of this, but these routing policies impact the customer. So how to solve this? So it's about sharing, and there is something which is very different from internet and in all the research work which has been done on pricing. Internet, you were looking for fairness. It's free. It's a free infrastructure. In the cloud, you have money coming from the tenant down to the provider, and the provider can charge for bandwidth. So fairness is not mandatory in the cloud. It has been proved by several research work, and of course, we tend to still desire work conservation. But pricing discrimination is certainly the right way to do. And in fact, it's what we have today. If you compare, that was here, if you compare the for example, the throughput you can get from different instance. So this experiment is just, you take an instance, for example, an M3 medium in VPC and another M3 medium. You measure it, and we did this, 24 hours, days, etc. You see how much throughput you can have from the internet network inside a same singular availability zone. You can do this with multiple availability zone, etc. And you see, the difference, and that's what you pay for. There is sort of proportional pricing for the instance in terms of CPU, in terms of memory. The proportionality is not completely respected here for network, but we can imagine that this will evolve. So the traffic and the demand is very variable, spatially and temporally, and a lot of unknown. And what is coming today is these advanced services which are coming. So we see sort of past aspects. So, for example, you have database services, you have big data services with Hadoop, and you have also network function virtualized. So you have your internal traffic, but you also rely for your global performance on external services which can be provided by the provider itself or provided by third party. And this contributes also to the traffic in the network. So that's a complex mix of traffic with intra-tenant, inter-tenant, as well as the internet traffic. So that's why we see all this research topic today. The network virtualization, as I presented before. We see, for example, in OpenStack, the Neutron group working on this, providing this virtual network abstraction for a tenant. We see all this work around network sharing, cloud network traffic analysis, and there is a topic about adaptation, because if you cannot guarantee anything in the network, you have to adapt. We have seen this for all the multimedia over internet, all the adaptation for voice over IP, video over IP. Is a lot of things in this, and we start to see, for example, Cloud Mirror or Cicada, and that's where Cloud River fits in. So. I don't know how much time I have still. Sorry? Still 10 minutes. Okay, good. So you have the application on top, and at the bottom you have the bare metal, the hardware. Then you have the virtualization layer. So hypervisor, we start seeing now software-defined storage, like what Scality is doing very well. And all this bucket of network virtualization, SDN, NFV, I put everything in the virtualization layer, which enables to have this as service. So exposed in green, it's what is exposed as service by a cloud provider. And the application have to deal with this. So they have silos, they have different type of resources, and they have to build their own infrastructure for deploying the application, or they build something. So, but what is about all the non-functional properties like availability, security, and predictability? That's where we put the application-defined infrastructure layer. So it's an abstract machine for running an application in the cloud and giving, consistent performance, predictability, and security. So Cloudweaver will provide you what we call the tenant application graph. And here is an example of what you get when you connect Cloudweaver to your infrastructure. So we have this notion of microservice. So we group resources, and for this we use a machine learning algorithm that will aggregate these resources in groups. And if you, for example, you expand it, you get, for example, this Cassandra cluster. And each entity here is actionable. You click on it, and you have the statistics on the usage of resource, and you can do this also on length. So you get TCP throughput, TCP RTT for this, and you can dive deeper in the metrics to see what the time series look like, and you can even compare. For example, in a group, you can compare the usage of resources in CPU, in disk, in memory, with the performance you can get from the network. And of course, this is abstracted from the physical. So you can imagine that this Cassandra cluster is on-premise. It's not necessarily in the cloud. The Cloudweaver model is agnostic to the physical infrastructure. If you remember where it is, you can see server which are can be virtual, exposed as service, or physical. So for doing this, we instrument the stack, and specifically we have module in the kernel in order to expose what you cannot see today if you monitor your servers or your disk. What is in between? The in between is not what you get from net in or net out. Net in, net out will give you only the metrics for how the door is open. It's not giving you anything about the pipes between each instance. And for discovering this, we have our sensors, which are open source sensors that you can put in your AMIs, and which will immediately give you access to these metrics. So typically, why latency is important? Latency variation impacts directly your throughput. So here, you see a noisy neighbor, so you see something happening on the network, so your latency is quite high, and that's what I showed before. So it's about 10 milliseconds minimum. You cannot have less than 10 milliseconds, for example, for this instance type, which is an M3 medium. And you have this, this spike, and which denotes cross traffic. And this, if you look at what you get here, has a direct impact on your performance. So about 2 milliseconds more in latency will decrease your throughput by 10 megabits. Of course, depending on the type of instance, you have different packet losses, and you will have this. We can, with what I explained before, do the root cause analysis. And all this cascading effect, because we can compare in time the different metrics. And of course, this is visualized, but we also do underneath by analyzing it. I will go very quickly. Okay, so you can try it for free. Yeah, there are a lot of data to gather, especially on the traffic and understanding, what the application in the cloud look like and how they communicate. So please join us. Thank you.
Do you have any questions?
Thank you for your presentation. From what you explained and presented, my understanding is that you're trying to make visible and understandable mechanisms and phenomena that might be hidden within the cloud of a provider. And this highlights the tension that cloud providers like Amazon have between hiding the dirty details on how they actually construct their data centers and place their VM and how they organize their network, and at the same time the impact of these decisions on the final quality of service that cloud users use. And what one could expect in the future would be that they would open more, provide more insight into how they actually place their VMs, organize their network. Do you think the cursor nowadays, in terms of transparency and opening up, is placed at the right position? And do you have any comments on how this might evolve, considering the pressures of the market or what different players might want to do?
Yeah, thank you very much. It's a very good question. I have this question every day for myself. I think that there is a competition between cloud providers. So there is a big hope that the situation will evolve. Even if it's not that easy to expose this, because even the cloud provider, have no real insight in what's going on for each customer. I do believe that transparency will be, at least not at the detail. We don't care about the routing policies and so on. It's just what we can get and how we can adapt the application to this. And sometimes, these bottlenecks are not created by the cloud provider. They are, I would say, more than 50% of the time created by the application itself. Because you have a large part of your network inside your server, from the socket layer down to the NIC. You have buffering, and we see different patterns which are not ideal for performance. But a tool like Cloudware can help visualizing, getting this data and understanding. So we help developers to see how the application communicates, and they can also improve the coding. So, but yeah, I think that the competition will help increasing this visibility.
And I've got a second question, which is not technical. So within EIT ICT Labs, we try to foster innovation and to link more closely teaching, research, and knowledge transfer and company creation. And so you're an example of someone who came from the French academic system, reached a very high level of visibility, created a company in France and decided to move to the Silicon Valley. Could you give a few inputs of what were the triggers for this decision, and whether this was something you had planned or you realized along the journey that you had to be in San Francisco if you wanted to be successful, and if yes, what were the reasons?
So it was not planned 10 years back at all, nor creating a company. It was just, because we had so much, and we have seen this cloud wave coming, say, okay, I cannot stay in the lab. I have to, to go to the real world. And we started in France, trying to find partners, and we talked to a lot, but most of the people say it's not in our agenda. We don't believe that the cloud will really be a big thing. So, and I was invited in US. I was working also with OpenFlow Lab at Stanford, and for me it was just obvious. So I made the decision very clearly in a few days, and I had to persuade an investor in Europe to help me to go there, because raising money in US is not that simple for a French or a European company. But we were lucky.
Any other